Welcome back to my channel, the place where soothing stories guide you into deep and peaceful sleep. Today, as always, I'll share a gentle tale to help you relax, unwind, and drift into beautiful dreams. Sleep is a magical remedy that recharges our energy, and there's nothing better than starting with a journey through the mysterious cosmos. In today's episode, we'll travel to Kepler-22b, a distant planet full of promise, potentially hiding secrets of extraterrestrial life. Let yourself sink into the story, letting images of shimmering oceans and eternal twilight zones carry you into sleep. I hope you enjoy the storytelling session and have a restful night. Imagine a planet 635 light-years away, where day and night might last forever, and vast oceans cover most of its surface. That's Kepler-22b, one of the most fascinating exoplanets humanity has ever discovered. This planet has all the conditions to potentially become a second Earth, but its mysteries could also make it a world beyond our wildest imagination, whether a dream or a nightmare. What secrets does this distant planet hold? What forms of life might evolve under its unique conditions? In 2011, while observing the cosmos, the Kepler Space Telescope made a groundbreaking discovery: a planet located in the habitable zone of a star, Kepler-22b. Kepler used an indirect detection method, tracking tiny changes in a star's brightness as a planet passes in front of it. This method, called the transit method, not only confirms a planet's existence but also measures its size, orbital period, distance from its host star, and even hints at its atmosphere. Kepler-22b's host star, named Kepler-22, is located about 6 quintillion kilometers from Earth. It's a yellow dwarf star, similar to our Sun, with a comparable size and an age of roughly 4 billion years. However, Kepler-22 emits about 20% less light than the Sun, making it invisible to the naked eye from Earth. The distance between Kepler-22b and its star is a critical factor. This planet orbits Kepler-22 about 15% closer than Earth does to the Sun. If placed in our solar system, its orbit would lie between Earth and Venus, potentially making it a scorching world like Venus. Yet, because Kepler-22 is about 25% less bright than the Sun, Kepler-22b receives less heat than Earth would in a similar position. This suggests that Kepler-22b's surface temperature could be comparable to Earth's, provided it orbits its star in a manner similar to Earth's orbit around the Sun. What would happen if Kepler-22b were tidally locked? In that case, one side of the planet would always face the star, bathed in perpetual daylight, while the other side would be shrouded in eternal darkness. This distribution of light and heat could create unique conditions in different regions, determining where life might thrive. On the constantly illuminated side, oceans could regulate temperatures, preventing overheating and potentially fostering an environment conducive to life. But what about the dark side? It might be a frozen world with oceans locked in ice, or perhaps a strange ecosystem could still exist in the darkness. Kepler-22b is one of the most promising exoplanets, yet it remains a great mystery. If humans could set foot here, will we find a new home or a world inhospitable to life? In this environment, organisms might adapt to perpetual light by using processes similar to photosynthesis to harness energy. However, there's a catch. If the planet's surface is mostly water, intense evaporation on the lit side could create a greenhouse effect. This water vapor could generate significant atmospheric pressure, forming thick clouds and triggering violent storms that lead to extreme temperatures. Such conditions could be highly unstable for complex life, making survival a formidable challenge. Picture a world immersed in eternal darkness, inhabited by eerie creatures adapted to absolute lightlessness. Under the reign of cold and darkness, devoid of the sunlight we're familiar with, could life exist in such conditions? At first glance, it seems unlikely, but Earth proves otherwise. On the dark side of the planet, organisms might rely on chemosynthesis, generating energy from chemical reactions rather than sunlight. Similar microorganisms have been found on Earth, thriving at hydrothermal vents deep in the oceans. These could form the basis of ecosystems, drawing chemical compounds from the planet's depths. Over time, animals on the dark side might evolve bioluminescence, producing light to attract prey or communicate in perpetual darkness. This light will become a vital survival tool. A world without sunlight is hard to imagine supporting complex life forms. Though Earth hosts unique creatures in deep ocean trenches and regions with extended polar nights, humanity has yet to discover life beyond our planet. For now, we can only speculate. The most intriguing area on Kepler-22b is the twilight zone, where light and darkness meet, creating intermediate conditions. Scientists believe this region could be the most hospitable for life. The temperature in the twilight zone might be stable enough to sustain liquid water on the surface, provided the planet has an atmosphere. Thanks to the balance between hot and cold, water here could exist as rivers, lakes, or even oceans. Intense evaporation from the lit side and cooling from the dark side could create an ideal climate for life to thrive. The first life forms might emerge in the twilight zone, gradually adapting to other regions, much like Earth's creatures have adapted to polar nights and ocean depths. Life on Kepler-22b could spread to regions of eternal light and darkness, developing unique adaptations. Though Kepler-22b's conditions remain a mystery, the tidal locking scenario offers rich research opportunities. Whether in the lit zone, the eternal dark, or the twilight zone, each region holds unique potential for life. Scientists believe the twilight zone is the most likely to support complex ecosystems. Future studies of this exoplanet may one day unravel the mysteries of worlds like Kepler-22b, and who knows, perhaps we'll discover the first extraterrestrial life in this balanced region. If Kepler-22b has an Earth-like atmosphere with moderate greenhouse effects, its surface temperature could be around 22 degrees Celsius, a comfortable level. However, its atmosphere might differ entirely or even be absent. Without an atmosphere, surface temperatures could plummet to minus 18 degrees Celsius. Conversely, if the atmosphere resembles Venus's thick, carbon dioxide-rich environment, temperatures could soar to 460 degrees Celsius, making it inhospitable. Fortunately, studies suggest Kepler-22b may have oceans capable of stabilizing temperatures, much like Earth's oceans have regulated climate for billions of years by storing and distributing heat evenly. It's also believed that Kepler-22b may hold abundant water. Much of its surface could be covered by oceans with an average depth of about 49 meters. Though this seems shallow compared to Earth's oceans, remember that Kepler-22b is about 2.4 times larger than Earth. Thus, the first challenge upon arriving will be finding land, which may be scarcer than on Earth. If you're lucky enough to find land, the next challenge is moving across it. The second surprise of Kepler-22b is its gravity. Being 2.4 times larger than Earth, scientists estimate its mass is about 36 times that of Earth, resulting in gravity approximately 6 times stronger. If you weigh 176.37 pounds on Earth, you weigh 1,058.22 pounds on Kepler-22b, making standing upright nearly impossible, let alone moving. Your spacesuit, weighing about 291.01 pounds on Earth, would feel like 1,746.06 pounds on Kepler-22b, an enormous burden. Before humans could travel here, engineers might need to develop specialized exoskeletons to support the back, legs, and arms, easing bodily strain. Without this technology, your journey could end the moment you step out of the spacecraft. And don't even think about falling. Be cautious of low-lying areas. A stumble into a small water-filled crevice could be inescapable, as free fall speeds could exceed 53.61 meters per second. Falling from a height of 49 meters, you'd hit the bottom in less than a second. Gravity doesn't just affect humans. It impacts all life on the planet. Trees on Kepler-22b would likely be short and sturdy, with thick, robust trunks to withstand immense pressure. Though growth would be limited, leaves and branches would be dense and compact to minimize damage from constant gravitational forces. To anchor themselves and maintain stability, native plants' root systems might be complex and deep, ensuring resilience in high-gravity conditions. The only organisms likely to reach impressive sizes are algae, supported by water and less affected by gravity. However, don't rush to dive in and verify this, as scientists haven't fully confirmed the existence of oceans on Kepler-22b. The water's composition remains unknown, and until samples are analyzed, it's best to avoid diving. If you adapt to life on Kepler-22b and stay long-term, prepare for more frequent birthdays. A year on Kepler-22b lasts only 290 days, shorter than an Earth year. But perhaps the most captivating aspect of exploring this Earth-like planet is the potential to find complex, diverse life, a hypothesis not without merit. If Kepler-22b has an Earth-like atmosphere and rotation, it could ensure a stable, habitable environment, located in the ideal Goldilocks zone, neither too far to be frozen nor too close to be a fiery hell. The present of confirmed oceans would suggest Kepler-22b is a world where complex life could form and evolve. What would that life look like? Given the high gravity, we can hypothesize that organisms would be fully adapted to it. Like trees, they might not grow large, resembling multi-legged reptiles to better distribute weight and move easily. These creatures would likely be low, muscular, and sturdy, with strong limbs adapted for high-gravity environments. Their bodies might be optimized to minimize energy use while navigating tough terrain. To protect against harsh external conditions, many species could develop exoskeletons or thick skin. These exoskeletons would likely be dense and durable yet flexible for mobility, possibly made of chitin or calcium, reinforced to withstand pressure and stress. Such exoskeletons would shield against physical damage and predators while maintaining body shape, preventing deformation under gravity's pull. In high-pressure conditions, they could protect internal organs from compression. Some animals might use exoskeletons for temperature regulation, with structures to dissipate or retain heat, crucial if the planet has wide temperature swings. Larger, taller creatures might exist underwater, where gravity's impact is less pronounced. As for flying creatures, you'd likely see none in Kepler. 22b skies. High gravity makes flight nearly impossible. These are all speculations based on models and hypotheses from astrobiologists and planetary scientists at NASA and other research organizations. We can't yet confirm these through observation. However, we hope future technology will enable detailed studies of Kepler-22b, potentially detecting signs of life if it exists. If the gravity estimate is inaccurate and it's only twice Earth's, human colonization prospects would improve significantly. In that case, the biggest obstacle would be distance. Kepler-22b is 635 light-years away, a short distance in cosmic terms, but an insurmountable challenge with current human capabilities. Colonizing distant planets like Kepler-22b remains impossible without a revolution in interstellar travel technology. These are still hypotheses, and we can't be certain they'll unfold as predicted. Much remains to be learned about the wondrous life forms a planet like Kepler-22b could harbor. Life in Earth's harsh conditions proves that even on seemingly inhospitable planets, life can emerge and thrive. Now, let's explore other exoplanets discovered by the Kepler telescope. In the search for habitable planets, scientists have sought Earth twins, planets with many similarities to our own. An Earth twin typically has a similar size, increasing the likelihood of a rocky surface, and orbits a star with size and radiation similar to the Sun, while maintaining an ideal distance in the Goldilocks zone. Kepler-452b was the first Earth-like planet found orbiting a Sun-like star, making it a prime candidate for life. In 2015, scientists deemed it the most Earth-like planet discovered, and for good reason. Like the Sun, Kepler-452 is a G-type star with a near-identical temperature, but is about 1.5 billion years older. Though slightly brighter and larger than the Sun, Kepler-452b receives only about 10% more energy than Earth, roughly 1.6 times Earth size. It has over a 50% chance of being rocky. Its orbit closely resembles Earth's, lying in the star's habitable zone, about 5% farther from its star than Earth is from the Sun. Scientists believe Kepler-452b had a head start on Earth in developing life, having spent 6 billion years in its system's habitable zone. This assumes it had the right conditions for life from the start. Studies support this, suggesting that if its atmosphere CO2 levels are similar to Earth's, it could be habitable. Kepler-452b is fascinating, but not the only promising Kepler planet, and its distance is vast. Even light takes 1,800 years to reach it. Using the fastest human-made object, the Parker Solar Probe, which hit a record 120 meters per second near the Sun, is an incredible feat yet. It's only 0.063% of light speed. A direct journey to Kepler-452b would take the probe 2.8 million years to cover 1,800 light years. At 500 light years away in the Cygnus constellation, the red dwarf star Kepler-186 hosts the first Earth-sized exoplanet found in a habitable zone. This boosted astronomers' confidence that many planets with Earth-like diameters exist, potentially with conditions for liquid water. Kepler-186f is less than 10% larger than Earth, with a 130-day orbit. It lies at the outer edge of the habitable zone, receiving about one-third the heat Earth gets from the Sun, similar to Mars. This isn't necessarily a drawback, but could be an advantage. Red dwarfs often have intense solar flares, doubling their brightness in minutes. But Kepler-186 is smaller, less massive, cooler, and dimmer than the Sun. Thus, despite frequent radiation bursts, Kepler-186b may be far enough to avoid deadly consequences. The potential for liquid water and life on Kepler-186b depends not only on its distance from its star, but also on its atmospheric conditions. Its position suggests surface water might be frozen, but its larger size could mean a thicker atmosphere than Earth's, retaining and distributing heat to keep water liquid. The system's other 4 planets, about half Earth size with short orbits, are too hot for life as we know it. With current technology, reaching Kepler-186b would take 780,000 years. But if we could build a spacecraft reaching 90% of light speed, descendants could arrive in 555 years. Meanwhile, we'll explore another remarkable planet, 1,100 light-years away in the Lyra constellation. Every 112 days, Kepler-442b orbits a K-type star at half the Earth-Sun distance. Such proximity could pose problems for life, as planets close to their stars are often tidally locked, with one side always facing the star, creating harsh conditions. However, Kepler-442b lies just outside the tidal locking boundary, potentially avoiding this fate. K-type stars are dimmer than the Sun, and Kepler-442 is smaller and cooler, so the planet orbits at an optimal 0.4 astronomical units, AU, from its star. How promising is Kepler-442b? Astronomers classify planets by habitability potential, a new scale. The Comparability Habitability Index, CHI, is being refined for greater accuracy than older methods. It considers a planet's composition, favoring rocky planets and orbital eccentricity, which affects light and heat stability from the host star. It also accounts for albedo, measuring energy reflected by the atmosphere. These factors are key to determining habitability. Like the Earth Similarity Index, ESI, CHI ranges from 0 to 1, with higher values indicating greater life-supporting potential. Kepler-442b scores 0.84 on both scales. Sadly, this planet is too faint and small for direct observation with current telescopes, and travel to Kepler-442b is impossible, as even the fastest probe would take 1.7 million years. However, we can study its biosphere. Research on radiation levels for a habitable exoplanet highlights Kepler-442b as a strong candidate, receiving enough light to support a vast ecosystem, potentially detectable by the James Webb Space Telescope, JWST. As JWST observes this world, we may expand research to other nearby exoplanets. One of the greatest challenges in studying distant worlds is the vast distance between us and them. Yet, we may not need ultra-advanced telescopes to solve this. Data from Kepler and the European Space Agency, ESA, suggests that half of all Sun-like stars may have rocky planets in their habitable zones. One might be hiding in our cosmic neighborhood, with a 95% chance of an Earth twin existing within 25 light-years. So, how long until we confirm a fully habitable planet near our solar system, and how will this discovery change humanity's history? Share your thoughts in the comments. And that's our journey through Kepler-22b, a mysterious planet with vast oceans and eternal twilight zones. I hope tonight's story has taken you on a gentle adventure, calming your mind and preparing you for a deep sleep. Thank you for joining me on this channel, where stories are crafted to lull you into beautiful dreams. Don't forget to like, subscribe, and turn on notifications to catch our next cosmic adventure. Wishing you a restful night and sweet dreams. See you in the next episode.